you to play with the default VPC, but then to set this up yourself, because when you set it up yourself, you get to choose what all of the variables should be. I haven't mentioned DNS, and in the last minute I'm going to mention DNS. Inside AWS, we provide you with DNS services as well. Those services are switched on by default, although you can switch them off, and they provide two things. They provide DNS resolution, so that your instances inside a VPC can resolve public addresses and addresses of other things in the VPC. And they also include the ability for us to assign DNS names to the instances, so you don't have to just use IP addresses. Now, that's really worth considering and looking at, but I'm not going to go into more detail here. I'm just going to say that if you're interested in DNS and not having to manage all of your own DNS, it's worth considering looking at Route 53. With that, I'd like to pass over to Tom, who's going to talk about some of the higher level services.
Thank you, Barry. Everyone. All right. So Perry has taken you through setting up your first VPC, connecting it to the internet, and securing it. And I'm going to go through how you can connect multiple VPCs on AWS, and how can you connect your VPCs back to your on-premise environment. So we'll start off with the options we have to connect VPCs in your AWS environment, in the cloud. And we'll look at two options. We'll look at VPC peering, and we'll look at transit gateway. Well, let's start with VPC peering. So Perry earlier compared the VPC to the equivalent of your data center on-premise, but running in the cloud. So VPC peering in that context would be like a piece of fiber, or like a leased line between those data centers. So if you have two VPCs you want to connect, you can establish a peering between them, and it can start communicating with each other. If you have another VPC that you need to connect to that environment, you can create another peering, and now the VPC in the middle can talk with both edge VPCs. However, one thing to remember here is VPC peering is a one-to-one relationship. So you can't have this path happening. You can't have traffic traversing a VPC to get to another VPC. So if you have a requirement for those edge VPCs to be able to talk to one another, you'll need to set up your own VPC peering here and establish a connection between them. So let's add a full VPC to the mix, and if you want to have any-to-any communication, we'll need to add additional peerings in here to have that happen. So all of the communication is happening privately, and the VPCs you're connecting over peering can be in different accounts, and they can even be in different AWS regions. So you can connect a VPC in Ireland with a VPC in the US. Finally, when you're connecting VPCs to each other over peering, you need to make sure that you don't overlap any of the side ranges you decided to use for your VPCs. From a setup point of view, establishing a VPC connection is very much a decentralized process. So the owner of each VPC is making a decision to establish that peering with the owner of the other VPC. So in this case, the owner of the VPC on the left is going to send a peering request to the owner of the VPC on the right, and then the owner of the VPC on the right will accept that request and the peering is established. Very simple. The final step is to update the routing tables on each side to make sure the traffic can flow. So if we zoom into the VPC on the left, we now see an additional routing entry in the routing table that's telling us how to reach the IP address range of the VPC on the right, and the destination is going to be the peering connection we just created. So last year we've announced the availability of another option for connecting your VPCs together, and that's the transit gateway. So if we go back to the world before the transit gateway, we can see our peering mesh again. And it's fine if you have just a few VPCs, but once you start getting into 10s, 12, 13, 20 VPCs, they need to connect to each other. It's becoming very complicated to manage. Plus, you will likely hit the limit of the VPC peerings a VPC can have. That's 125. So how does Transit Gateway help us? So Transit Gateway is a distributed, managed routing service that you deploy into a region, and you can connect and attach VPCs in that same region to your Transit Gateway, and then allow for any-to-any communication from a routing point of view, or you can isolate some VPCs to allow them only to talk to each other. So if we now add some routing information here, and we assume that all our VPCs are in the 172.16 block, how is our routing going to look like inside our VPC? So if we zoom into that routing table, we now see a different entry that's pointing to any addresses in the 173 block and saying that those addresses are now reachable via the transit gateway. So rather than having a single entry per peering like we had before, we can now have a single entry sending all the traffic to the transit gateway, and then the transit gateway actually has its own routing table with specific information about every single attachment it has, including the VPC that we're sending traffic from. So communication, similar to peering, is happening completely privately. Your transit gateway and your VPCs can be in different AWS accounts. However, the transit gateway and the VPCs have to be in the same region. We've announced end of last year that we are planning for this year to make connectivity between transit gateways in different regions available, but that's coming. Okay, so if you're comparing the two and making a decision which one to pick, which technology to pick, VPC peering or transit gateway, here's some ideas. You can look at some comparison numbers that you can look at, but in the end, it's going to come down to the number of connections you can have and how easy it is to manage that environment. So if you're configuring more than 10, 15 VPCs, transit gateway is probably something you want to look at. Okay, so we've connected our VPCs on AWS. Let's start connecting them back to on-premise. So we'll go through a scenario where we have an on-premise environment on the left, and we will have our VPC on the right. And we'll look at two connectivity options. We have AWS site-to-site VPN. That's effectively an IPsec VPN tunnel, typically running over the internet, connecting your VPC to on-premise. And the other option is AWS Direct Connect. That's a dedicated physical connectivity into the AWS backbone. So VPN is often the starting point for many customers. It's an easy thing to set up, and you can do it with not a lot of effort. So to set up your first VPN, first of all, you need to define the customer gateway, and this is going to be the on-premise end of your VPN connection. And this could be your router, your firewall, anything you manage on-premise that supports IPsec. On the VPC side, you'll create another gateway, a virtual private gateway, that you associate to your VPC, and that will be the other side of your VPN connection. So once you have those two endpoints, you can create your first tunnel, you can create your first connection, and each VPN connection actually consists out of two separate IPsec tunnels. And the reason why there's two separate tunnels is because we give you two separate VPN termination endpoints in different availability zones for high availability. Finally, if you're not using a dynamic routing protocol, like BGP for example, you would have to update the routing table inside the VPC to tell it how to reach the on-premise range. So VPN is great, but because it often runs over the internet, you might sometimes have some unpredictable experience. So if you want more predictable and consistent experience for your connectivity to AWS, that's when you would look at AWS Direct Connect. And here, first of all, we're going to zoom out a little bit from our VPC and look at the larger AWS cloud. And then inside, we have our VPC we created earlier, but outside of that VPC, that private environment, we have other services. These services are managed services that live on the AWS public address space. These are things like S3, DynamoDB, CloudWatch for monitoring. All those services are outside of your VPC. And now we want to use Direct Connect to connect from our on-premise environment both to our private VPC, but also to some of those services that are on the public address space. To do that, we would use one of our Direct Connect locations. These are locations that we publish on our website. You can pick the location that's closest to where your data center is. And in each one of those locations, AWS will have a number of routers that we manage, and then you request a port on one of those routers, maybe 1 gig or 10 gigabits a second, and then you can establish physical connectivity to that port, either yourself or with the help of an AWS connectivity partner. So this is just your physical connection. On top of that, you now need to start creating your logical connectivity, so your virtual interfaces or VLANs on your side. So first you can create a private virtual interface. That is an interface that gets you connectivity into your private environment, into the VPC. and for connectivity to outside of that VPC, to the publicly addressed services, you could use the public virtual interface. Now, if you're connecting to more than just a single VPC, and you want to use a single logical connection, for that you can use AWS Direct Connect Gateway. In that case, you would create a single logical virtual interface, terminate it on the Direct Connect Gateway, that then can connect to up to 10 VPCs that live in the same region or in different regions across the world, except for China. Okay, so if we now start connecting multiple VPCs, and we look at the time before we had Transit Gateway available, if we're connecting our VPCs back to on-premise using AWS site-to-site VPN, we would have to create a VPN per VPC. So each VPC would have its own VPN connection. If we had 100 VPCs, that means 100 VPN connections, actually 200 because there's 200 tunnels. If we're connecting back to on-premise using Direct Connect, then in that case we could leverage Direct Connect Gateway and maybe have that single logical interface connecting to up to 10 VPCs. With Transit Gateway, we already know that Transit Gateway can help us aggregate the connectivity in a certain region, and we can connect up to 5,000 VPCs to a single Transit Gateway. But now it can also help us consolidate that connectivity back to on-premise. So instead of setting up a VPN tunnel to every single VPC, we can now have a single tunnel going to the Transit Gateway, and from there we can reach all the VPCs attached to it. If we're using Direct Connect, and this is currently only available in the US, we could use Direct Connect Gateway to connect a single logical interface to the Direct Connect Gateway and effectively to the Transit Gateway to reach all the VPCs. Now, from a routing point of view, it's still very simple. So all you need to do is now add an additional entry to tell the VPC how to get to the on-premise address range, and you just point it through the Transit Gateway. And the Transit Gateway is going to have its own entry for the connectivity back to on-premise. In this example, we're using a VPN, but it could be Direct Connect. So we've created a hybrid environment. We now have on-premise environment connected to AWS. But what about DNS? So typically, customers would have private domains, private zones deployed on-premise as well as on AWS, and they want to be able to resolve them no matter where they are. So for that, we have Route 53 Resolver service that allows you to create resolver endpoints in one of the VPCs connected to on-premise to be used for DNS forwarding. So you can do that resolution from on-premise to AWS and vice versa. And you can even create your own forwarding rules to specify which domains should stay on AWS and be resolved on AWS, and which ones should be forwarded back to your on-premise service. Okay, so it's been quite a busy year for networking.